we are proving the converse part of simple approximation theorem. So in a previous video I have explained you have to prove these three things here by assuming f is measurable. So in the previous video I have explained how to prove the pi n is simple function on E. You can get that in my playlist. Okay, go to my playlist. There you can see measure and integration. Within that you can see a lot of videos. So there you can get the proof of this theorem. Okay. There you can see the previous video of this converse part. So here now we are proving the second one, that is pi n converges pointwise on E to F. Okay. So here I am writing that to prove pi n converges pointwise on E to F. To prove this, what you are doing is first you are considering the function, that is f. This f is a real valued function. Okay, and then you are writing, we write f equal to f plus minus f minus. That is how you are writing. You are considering like this. Okay, f is equal to f plus minus f minus. So here f plus and f minus are the non-negative measurable functions. Okay, in the above line you have told about what is f. F is a real valued function, and now you are writing that f equal to f plus minus f minus. So you have to tell about f plus and f minus also, right? So that is why here in the next line you are writing this f plus, where f plus and f minus are the non-negative measurable functions. Now you are applying simple approximation lemma, so that here you are writing okay, in the format of simple approximation lemma, that is there exists sequence of simple function. Already in the here you have wrote pi n. Okay, in the previous part also you applied a simple approximation lemma to f restricted to en. There you have wrote there exists pi n and psi n. So to show the difference, instead of taking simple functions pi n and psi n, in this part you are taking pi n dash and psi n dash. Okay, so there exists sequence of simple functions pi n dash and psi n dash such that pi n dash converges to f plus and psi n dash converges to f minus, and then you are writing the properties that you have in the simple approximation lemma, that is 0 less than or equal to, that is the simple function lies between 0 and f plus, and another simple function, that is psi n dash lies between 0 and f minus. That is how you are writing by the by simple approximation lemma, using simple approximation lemma. Now after that what you are doing is, let pi n is equal to, you are defining like this, let pi n is equal to pi n dash minus psi n dash. Now you are taking limit, so that you will get limit n tends to infinitive pi n is equal to limit n tends to infinitive pi n dash minus this minus, and limit n tends to infinitive psi n dash. So here limit n tends to infinitive pi n dash, the value of this is f plus, and put this minus, and here the value of this is f minus, so that you get this. So you got limit n tends to infinitive pi n equal to f. From this you can say what? Pi n converges to f pointwise. Okay, and then you are proving the next also by star. Also in the statement you have to prove this property also. Okay, I missed to write it here. I missed that to write it here. Okay, you have to prove that also. You are proving that needs not a lengthy proof. In a single line you can write it, that is by star. Here you have an equation just before this proof. Just before this line you have wrote that in proving pi n is a simple function on E, you got this inequality, right? So by star you can write this. so that you have proved this also. I will show you. You can see that by star we have this. Okay, now we have to prove if f is non-negative, pi n is increasing. That is what we have to prove. So first you are choosing f is non-negative, then let pi n is equal to maximum. You are choosing the value of pi n is equal to maximum of pi 1, pi 2, etc. pi n. So it means what? When you take the maximum value, the pi n value will start increasing, right? Because you are, for pi n, you are choosing maximum values, so that when you find pi 1, you will get the maximum value. When you find the pi 2, you will get the maximum value. Right, so that your pi n will be increasing. So that is how you proved this also. Hence you have proved all the conditions that you have proved in the converse part. So thus the theorem comes to an end.